All right, guys. First off, I forgot to mention do exercise 23. That was at the end of the last one. So if you haven't, go ahead and pause this video and do exercise 23 out of the section 3.1 book. Okay, I'll assume you've done 23. You're back. Let's talk about data. What if you just have a table of data? Can you find derivatives? And the answer is sure. It's going to be an approximation, but we can actually find derivatives of data because it's sometimes useful to know how fast something is changing, even if we just have a bunch of discrete data points. So the problem we're going to look at is the probability of two people in a room having a shared birthday. Surprisingly, it turns out that by the time you get to 70 people in a room, there's almost 100% chance that two of them will share a birthday, which is sort of weird given that there's 365 days in the year. But that's just the way the data works out. And what I've done here, this is on page 105 of your book, if you want to go look at the data. I've copied down the first few rows of data, and I've also created a copy of the scatter plot here. And you can see that it starts out fairly flat and then it gets very steep. The probability is changing rapidly. And then by the time you get up towards the top, it's starting to get pretty flat again. So how do we graph the derivative of this function? Well, what we're going to do is we're going to approximate each set of data points. We're going to take the first two data points and we're going to say, well, let's say that at 2.5, halfway between 0 and 5, that the change in y can be over change in x can be the average. And so what we'll do is we'll say 0.027 divided by, or minus 0 divided by 5 minus 0, the rate of change in y over change in x, and I'm going to make a new column here, is 0.0054. So now let's do the next set of points. I'm going to average the two at 7.5. We'll take 0.117 minus 0.027 divided by 10 minus 5. Notice we're dividing by 5 every time. And on average, the average rate of change between 5 people and 10 people in a room, 0.0180. And we'll do this for 12.5. We'll do this for 17.5, and so on all the way down. Again, page 105, you'll notice there's a complete table with all of the values, and we can go 0.0316. I'm not going to show you all of them because I think it's pretty obvious. But if I turn to page 106 and I want to graph the derivatives, I'm going to do them on another set of axes here. The derivatives, what we notice is that, again, it starts low, and our points are all going to be in between the points on our original graph. And it goes up, and the slope reaches a maximum. And notice that maximum right there is going to be somewhere in here where this graph is the steepest. Can we connect the dots? We could curve fit something, and that's probably what we would do if we wanted an equation. We'd curve fit an equation so that we had some equation that we could use to do calculations and say, well, what if we had 32 people in a row? There'd be something in there. All right. So, guys, that's from data. The key on data, I'll just synopsize this here. Average rate of change in between data points. Why don't you guys go ahead and do exercise 29, which will ask you to do some of these calculations, and I'll be back with the next video.